Hi, I'm Ben Smith, and today I'm going to be talking about stream health and how statistics can help us see what is going on in stream ecosystems, as well as devise strategies to mitigate harmful effects on these ecosystems. In this process, I have a brief overview of the multiple linear regression and how it is used to identify relationships that explain the data we collect on site. To get us started, I'll start with a story. You walk upon a stream similar to the one pictured. On the surface, it looks like it's perfectly healthy. Sure, maybe it's not perfectly clear, but the water is mostly transparent with some mossy rocks scattered in the stream. Unseen to the blind eye, though, there can be many things going on that seriously affect the health of the stream and the organisms that rely on it to survive. For example, nitrogen levels in the stream could be too high, then causing excessive plant growth. When plants in the stream die, their decay process uses a lot of oxygen, thereby reducing the oxygen supply to the stream and potentially causing the death of many other organisms in the stream that require oxygen to live, such as our little fish here. That's where our research question comes in. What factors might be affecting these streams that we can't see? Are there some outside factors influencing the stream's health that we could work to reduce in order to maintain the beauty of the streams that we see? As a result of this question, we turned our focus to a prominent industry here in Arkansas, the poultry industry. Chicken houses are a prominent source of nitrogen and phosphorus due to the large amounts of chicken litter produced by the chickens. Chicken litter is commonly used as fertilizer due to its high nitrogen and phosphorus levels. When it rains, however, this nutrient-rich litter washes into nearby streams over time. Our research centers on the effects that this runoff has on local streams. In order to explore the effects of chicken litter on local streams, I used the data collected by Allison and Victoria as part of their research and began to analyze it. After a little bit of data entry, which ended up being fairly tedious, and organization in Excel, I was ready to start investigating some of the causes of what we were seeing in the stream data. The first step in analyzing a research question is deciding what tests to use. There are a lot of statistical tests out there, but for this particular research question, we have many things that can cause a response in the environment we are looking at, so it makes a lot of sense for us to use a multivariate test. We also want to use a regression, which allows us to find relationships between the variables. Combining both of these things, we decided on a multiple linear regression. Before I get into analyzing our results, though, I want to give a quick overview of what exactly a multiple linear regression is. Here we have a generic scatter plot, and we need to find the line of best fit. The process of finding the line of best fit gives us a linear equation of the form y equals mx plus b. This equation is a relationship that we can use to predict the effects of a predictor x on a response variable, y. The main difference between a simple linear regression, like the one on the previous slide, and a multiple linear regression is the fact that in a multiple linear regression we are testing the effect of multiple predictors, or x's, on the same response, y. This makes graphing the multiple linear regression much harder than graphing a normal simple linear regression, so we rely on software that does that for us. Since we are choosing multiple predictors, or x's, it's very helpful to have a way to organize the different sets of predictors for each response. In order to do this effectively, I use an approach that uses models that are scored based on their accuracy according to the multiple linear regression. All in all, I came up with 15 models to test, 5 models for each of the 3 response variables I chose. For my response variables, I chose the concentrations of nitrate, soluble reactive phosphorus, and chlorophyll A in the water. Nitrate is essential for plant growth and can be found in fertilizer, manure, and also rises from rainfall. Phosphorus is very similar and can also be found in manure and fertilizer as well. Chlorophyll A is a pigment used in photosynthesis and gives an image of plant life in the stream. My predictors varied for each response variable, and each model was scored relative to each other model in the response group. In the chlorophyll A group, 3 models were significant, with one accounting for over 40% of the variation in our data, and the other accounting for almost 70% of the variation. In these models, we found significant relationships between 2 predictors and the response. The first of these significant relationships is between chicken house proximity and the response, chlorophyll A. Following the example that I gave earlier, the connection between these two factors is clear. The nitrogen and phosphorus from the chicken litter runs off into the stream when it rains, causing increased plant growth, thereby increasing the amount of chlorophyll A in the water, since chlorophyll A is involved in photosynthesis. As for the second predictor-response relationship, it's a little more nuanced. The predictor for this relationship is discharge, or the rate at which water leaves the stream system. It varies based on several factors such as width, depth, and the speed at which the water is moving in the stream. When discharge is low, this causes the water to pool, allowing nutrients collected there to be easier taken up by the plants, increasing chlorophyll A levels. As a result of both of these relationships, plant growth is increasing. Although this doesn't sound like too bad of a thing on the surface, as I described earlier, increased plant growth can lead to decreased oxygen levels if it gets out of hand, which will in turn start to cause the death of organisms that require oxygen to live. The lack of oxygen is catastrophic to the stream ecosystem, and it can take a long time to recover, if at all. There are a few outlying things that are unclear with our data, however. The chicken house proximity showed no relationship with nitrate or phosphorus concentration. This could be due to a multitude of factors. I have chosen the wrong group of predictors to highlight the effects of chicken house proximity on nitrate and phosphorus concentration. There could also be environmental factors that I didn't consider. For example, the data I analyzed was collected over the summer months where there is typically less rainfall. This reduces the amount of nitrate and phosphorus leaching into the water, and the low rainfall also serves to lower discharge, promoting plant growth and thereby increasing the chlorophyll A concentration. In order to further explore these effects, extending the time frame of our measurements would help to further establish the relationships we found. Despite these outlying factors, we were able to show that a relationship between chicken houses and chlorophyll A does exist. This discovery allows us to develop strategies to mitigate the impact that chicken houses have on our local streams. For example, regulations that ensure that chicken houses are not placed within certain distance of stream are helpful, as well as the planting of trees and other plants that reduce the amount of runoff getting into streams. If we employ these strategies based on the trends that we see in the data, we can be confident that we can maintain our local streams not just for our lifetime, but even in the lifetimes of our children and grandchildren. We as humans have had a huge impact on the Earth as we've used its resources throughout our history, and we need to be aware of just how much damage we can cause, taking steps to maintain the Earth's health where we can. Here are some of the references used to create this presentation. I want to thank Dr. Dodd for giving me the opportunity to work with her on this project for my honors contract, as well as for agreeing to work with me this semester on this presentation. I also want to thank Dr. Buby for taking the time to teach us about public scholarship during this course, as well as offer suggestions for improving each and every one of our individual presentations as we made our way through the course. Lastly, I want to thank you all for listening. Hope you enjoyed.